Hello children, so this is the third video of similar triangles, and in that the first exercise, that is theorem BPT, basic proportionality theorem, the application questions of basic proportionality theorem and converse of basic proportionality theorem. Children, you should understand that when we learn one theorem, we have got question based on that. Those are called application theorem, and there are certain theorems also proved applying those theorems which we previously know. So we know basic proportionality theorem. One of the theorem which has come or derived from basic proportionality theorem is the internal angle bisector theorem. Now what does it state? It says the angle bisector of any angle of a triangle, that means AD is the angle bisector, divides the opposite sides in the ratio of the sides containing the angle, in the ratio of the sides containing the angle. That means AD will divide the opposite side, that is BD and DC, in the ratio of the sides containing the angle, that is AB and AC side contain the angle BAC. So that means given a triangle ABC in which AD is the angle bisector, I have written a triangle ABC in which AD is the angle bisector of BAC. What has to be proved is the side containing the angle AB by AC ratio is equal to the opposite side ratio which has been divided by AD. So AB by AC is equal to BD by DC has to be proved. So here we will do a construction so that we will be able to apply BPT over here, basic proportionality theorem. So what we will do is we will draw a line through C. We will draw a line through C parallel to AD. So we are drawing a line through C exactly parallel to AD. Exactly parallel to AD, whatever amount I can go, which meets BA produced, so BA produced at K. That is what I have written over there. Have a look. So this is what I have written. We draw a line through C parallel to AD which meets BA produced at K. So here so the proof is very easy, because now you can apply BPT, this by this is equal to this by this, because AD is parallel to CK. That is easy now. Only thing is, now what has to be done is the angle bisector is given. These lines are parallel, so if this angle is theta, that means angle DAC will be equal to angle ACK, alternate angle, isn't it? So I am going to write that in proof now. Proof angle DAC is equal to angle ACK, alternate angles, isn't it? These two are alternate angles, because since AD is parallel to CK and CA becomes the transversal. Same way, this angle is equal to theta also, that is angle BAD is equal to angle AKC each. Why? Because they are corresponding angles. Have a look. Corresponding angle, this angle is equal to this angle because this is the angle bisector, isn't it? And also this is parallel to this line. So now what do we see is that DAC is equal to BAD. Already it was given, but it was given DAC is equal to DAC is equal to DAB or BAD. DAC is equal to BAD, it was given, isn't it? So that means it was given. So DAC and BAD are equal, that means ACK and AKC also will be equal. This implies that ACK is equal to AKC. So in this triangle ACK is equal to AKC in triangle ACK. So if base angles are equal, then the sides are equal. If base angles are equal, then AC is equal to AK. AC is equal to AK. Now our work is finished, our operation is finished. because now we can straight away apply BPT and replace AK by AC. Now in the larger triangle, that is triangle BCK, DA is parallel, AD is parallel to, or DA is parallel to CK, AD is parallel to KC, I can write. Alright, this implies that we can now apply BPT. So BD by DC is equal to BA by AK, BA, or I can write AK by BA by AK or AB by AK by BPT, basic proportionality theorem. So BD by DC is equal to AB by AK. Now we will replace AK by AC. So BD by DC is equal to AB by, instead of AK we have proved already that AK is equal to AC, so we have proved it now. So it has been proved, QED. BD by DC is equal to AB by AC, or AB by AC is equal to BD by DC. This is how angle bisector theorem operates. Now once we know this, now directly we can apply it to different questions. Here they are telling that in the given figure, let us make a figure. In the given figure, AD bisects angle BAC. Alright, AD bisects angle BAC. That means if this is theta, this is theta. So obviously we will conclude, since AD bisects angle BAC, now we can straight away apply the angle bisector theorem. What is that? This implies that the sides containing the angle AB by AC will be equal to BD by DC. Now AB is, we have to find AC. AB is 6.8, it's given, divided by AC is not given, is equal to BD is 8 and BC is 20. If BC is 20 and BD is 8, that means CD will be 12. So I will put it as 12. Alright, so DC is 12. So this becomes, let us see, this becomes 4 2s are 8 and 4 3s are. So now AC will be equal to 6.8 into 3 divided by 2. 2 3s are 4s are. So AC will be 10.2. So AC will be how much? 10.2. So did you all understand this? This is the first part. Let us once again see the calculation. AB is 6.8, AC is to be known, BD is 8 and whole BC is 20, so it is 12. 4 2s are 8, 4 3s are 12. 6.8 into 3 is equal to, divided by 2 is equal to AC 2. 2 3s are 6, 2 4s are 8, 3 4s are 12, 1 3 3. So this is 10.2 centimeters. Alright, so done. Same way the second question can be done. I will leave it on you to find the value of x, or let me see if we can do that for you. Let us see. So I am removing this, I am removing this. Now we have to write AB is equal to 3x, AC is equal to 3x, AC is equal to 2x plus 2. This is x plus 2.5 and this is x 2x minus 4. 2x minus 4. So what we write is 3x divided by 2x plus 2 is equal to, now BD is x plus 2.5 is equal to, divided by 2x minus 4. So we will cross multiply and then we will get a quadratic equation. We solve that quadratic equation, we will get the answer. Alright, so this you can further proceed. 3x into 2x minus 4 is equal to x into 2x, x plus 2.5, x plus 2.5 into 2x plus 2, and then you can sort it out by converting it into a quadratic equation. I should leave it there for you all, so that you can further calculate and get the value of x using the quadratic equation. Now the other question which I would like to solve is this one. So I am rubbing the board to get the board space, because this will take time and explanation. Now this question everybody should do, because it is combination of all the three, the BPT, the converse of BPT, most probably the angle bisector and the converse of BPT. Have a look. They are telling, they have given a triangle ABC. The first thing is AD is the median. That means first thing is given is BD is equal to DC. So BD is equal to DC given. BD is equal to DC given. Now only we will concentrate on this side. Now second thing they are giving is D is angle bisector. D is angle bisector. They are taking it as x and x. So I will put it also x and x. D is angle bisector. So in this triangle we can apply the angle bisector. In triangle ABD, since DE bisects angle ADB, therefore AD by DB is equal to AE by EB. Just have a look. You can rotate your copy, then you will get this in this shape, the angle bisector. So angle bisector which we learned. So this is equation 1. Now the other side is DF. Now this is y and this is y. So this side also we can apply. In triangle ADC, DF bisects angle ADC. This implies that AD by DC is equal to AF by FC, but DC is equal to BD. So this further we can replace. This is by angle bisector, this is by angle bisector. So we can write here by angle bisector theorem. Now what will happen? Let us see, DC is replaced by BD. So AD by BD or DB is equal to, BD or DB is the same thing, is equal to AF by FC. So from 1 and 2 what is happening? AD by DB is equal to AE by EB and AD by DE is equal to AF by FC. So this implies that from 1 and 2 AE by EB is equal to AF by FC. So what is happening now in the larger triangle? In triangle ABC, what is happening? Now I will join this. What is happening? AE by EB is equal to AF by FC. This implies that by converse of BPT, if a line divides any two sides of a triangle proportionally, that means it is parallel to the third side. That means EF is parallel to BC by converse of BPT. Converse of BPT. So children, see, sometimes in certain question application of two theorem. Here we have used angle bisector theorem in two triangles, and then we have used the converse of BPT and we have come to the conclusion. So focus on this, try to rewind and see the proof, and then again try to do the questions, and one question I have left you to solve using quadratic equation so that you will be able to solve. Thank you.